The Goldilocks approach to feeders is a deep dive into the inner workings of planning analytics. Feeders are the main character in the story, and feeders live in TeamOne, the core of planning analytics. My name is Dan Swan, and I'm a consultant with PM Square. I have over 10 years experience building budgeting and forecasting models, and I've worked with TeamOne for over 6 years. Our agenda during this presentation will cover TeamOne and planning analytics, features, the applications, model objects, consolidation process, rules and feeders, and much more. We will mainly focus on feeders and their impact on the TeamOne model. TeamOne is an OLAP tool that uses 64-bit in-memory technology to deliver enterprise-ready, responsive solutions for budgeting, forecasting, planning, and what-if scenarios. TeamOne is the engine that supports all planning analytics applications. Workspace, a web-based application, is IBM's newest app for TeamOne. It uses a more graphic user interface that can help simplify the user experience. TeamOne Web is also a web-based app that has the look and feel of a spreadsheet and can satisfy more demanding users. Tax, or planning analytics for Excel, can meet the demand of power users who work primarily in Excel. Perspectives is the original Excel-based application and is also used by sophisticated Excel users. All of these applications rely on TeamOne for data, data structures, and data security. TeamOne is comprised of several key objects. Dimensions are a list of common elements such as accounts, months, departments, etc. In Excel, a dimension might be expressed in a row or a column. Each dimension can represent a separate parameter that someone in your company might ask about, such as, what were the sales in the North American region for the month of July of this year? Each parameter of the question, sales, region, and month, can represent a separate dimension. Dimensions properly assembled could answer this question. A cube is a combination of two or more dimensions. More about this in a minute. Rules are calculations that perform math, move, and transform data. They're contained in a rule file for each cube. Our main character, feeders, are an integral part of the rule file. We will be discussing rules in more detail shortly. Processes are standalone programs within TeamOne that can load data into cubes, move data between cubes, and can build, modify, or delete dimensions in cubes. Processes can also load data from text files or query a database directly through an ODBC connection. SQL and Oracle are examples of databases that can be queried by TeamOne. Chores are collections of processes that can be scheduled and run at specific times, running processes in a specific order each time. Control objects mainly consist of cubes that control the model behavior and security. We can leverage control objects to provide information on the model state and to extend security throughout the model. As I mentioned earlier, a cube is made up of two or more dimensions. The cube can have a specific or general purpose. It can be used exclusively to perform specialized calculations, or it can be used to just support reporting and analysis. Cubes are the objects users interact with the most. They house the data users need for reports and analysis, and they can accept data input from users for budgets, forecasts, or commentary. The intersections of dimensions make up cells that house data. A single cell could contain the answer to a question regarding units solved, for example, Sedan 1 in February. In this example, we have 3 dimensions: product, month, measures. We could add more dimensions such as sales region and year to make the cube more powerful. Calculate the size of the cube, multiply the number of elements in each dimension. In our example here, we have 100 accounts, 30 departments, 8 lines of business, 26 time elements, and 20 locations. Multiply all those elements together and you get a total of 12,480,000 cells. Add just one more dimension for scenario, budget, forecast, and actuals, and you get 37,440,000 cells. TeamOne may perform calculations on many of the cells created, so the need for efficiency is very important. You may want to limit the number of dimensions you use in any given cube, because as cubes get larger, response time can be impacted. The Consolidation Engine is a built-in TeamOne algorithm that is engaged simply by arranging the elements of a dimension in a parent-child hierarchy. When you do this, TeamOne will automatically sum the components, and no code has to be written by the developer. You can also change the weight of an element. The weight is either positive or negative. If you want to subtract the amount in an element, make the weight negative. By default, the weight is positive. So if you change nothing at all, the data will sum to the parent. And in our example here, cooking gear, tents, sleeping bags, packs, and lanterns roll up to camping equipment. Camping equipment rolls directly to all products. So simply by arranging it this way, the system will sum up all the data for cooking gear through packs and lanterns to camping equipment. And camping equipment, mountaineering equipment, and personal accessories will roll up to all products. Let's go into Architect, the primary tool for TeamOne modelers, and see how a hierarchy can be created. We'll edit the products dimension. So you can see there's simply a list of products and product categories. We'll select components of camping equipment, drag those up, drop them on camping equipment. And we'll take camping equipment, mountaineering equipment, and personal accessories, drag those up and drop them on all products. And now we have hierarchy within our product dimension. Everything rolls up to all products. Cooking gear, tents, sleeping bags, packs, and lanterns roll up to camping equipment. So now, data contained in camping equipment and all products will roll up. Skip check, rules, and feeders. Skip check is a fast consolidation algorithm, and it's turned on by default. Skip check skips all cells with a 0 value. As you can imagine, most cubes can be sparse, meaning there are a lot of cells containing zeros. This makes sense because we may not be selling every product in every region during every month. There may be regions where some products are never sold. Regardless, we want to skip 0 values to improve the efficiency of our cube. When a rule file is created for a cube, the skip check function is automatically turned off because there's a problem with skip check. He has a blind spot. You can't see the results of a rule. They all appear as a 0, so he skips rule calculated cells, and that can be bad. Skip check doesn't care anything about a rule unless a feeder indicates that a cell is the target of a rule. A feeder puts a marker or flag in a rule-driven cell so that skip check knows a cell contains a value. Since skip check is turned off when a rule file is created, you'll want to turn the Consolidation Engine back on by adding the skip check function at the beginning of the rule. There are two general types of rules. One, a calculation within a cube. In our example, quantity times price equals sales. And two, a rule that pulls data from another cube. In this example, we're pulling cost from the cost cube. The left side of the rule is the target. The target might be one cell or several cells. The left side can be a combination of calculated data and data pulled in from one or multiple cubes. Rules can contain if-then conditional statements, specialized TeamOne functions, or simple math, as we have here in our example. Looking at feeders within the same cube, here we have our simple calculation again of quantity times price equals sales. And we have a feeder. Quantity is pointing to sales. Why did I choose quantity to feed this rule? Because I only want to feed sales when there's a quantity sold. If nothing is sold, then the feeder will not fire. This makes skip check more efficient because he can skip a cell with no sales. If the feeder were to place a flag in every cell containing the sales calculation, then we would lose the advantages that skip check gives us. Note that the left side of the feeder statement contains the source of the feeder value, and the right side is the recipient area. This is the opposite of a rule. Cost is a target for recipient of data from the cost cube. We have to feed from the cost cube, which points to the target cost within the sales cubes. We always want to feed from a cell with data, and it's best to feed from a cell whose content changes in conjunction with the target. And in this case, the cost is always going to flow to cost to the sales cube. Overfeeding can occur when you feed to cells that don't contain rules, or you feed rule-driven cells that result in a zero value. In the simple example we showed earlier, sales are dependent on the quantity sold, so we're safe feeding from quantity. If we fed using the price, we would overfeed because every product has a price for every region, every month, etc. As a result, the consolidation algorithm would be working too hard. However, in an overfeeding situation, your consolidated values would be correct. Underfeeding can occur when some or all calculated cells are not fed, which can cause consolidations to be zero or incorrect. Underfeeding means the consolidation engine is skipping cells with values. Underfeeding can happen when you feed from a value that doesn't correlate with the calculation, or sometimes your feeder can miss the target entirely. When that happens, it can be apparent very quickly because the consolidations will be zero. When cells are fed just right, feeders are targeting the right cells and rules are performing efficiently. And most importantly, consolidated values are correct. To test feeders, right-click on a cell and select Check Feeders to see if the cell is being fed. To trace a feeder, right-click on the source of a feed, select Trace Feeders to see what the cell is feeding. Let's go back into Architect and see exactly how the addition of feeders impact a cube. So we're going into our best practice model. We have applications, cubes, dimensions, processes, chores. We have one cube, income statement cube, that contains accounts, months, products, regions, and years dimensions. We also have two views of the income statement cube, and we have an income statement rule file. Let's look at the products dimension. We can see it's just a simple list. It's not a hierarchy at this point. And if we look in our revenue view, we can see that nothing is rolling up to all products. Nothing is rolling up to camping gear. So let's go back into our products dimension and arrange it as a hierarchy, putting cooking gear, tents, sleeping bags, packs, and lanterns underneath camping equipment, and taking camping equipment, mountaineering equipment, and personal accessories and rolling that up to all products. Now we have a product hierarchy within our product dimension. Let's save that. Click OK. And now let's go back into our revenue by product view. Now we have roll-up values for camping equipment and all products. So simply by arranging products in a hierarchy, the system will automatically create totals for all products and camping equipment in all regions for all years without any code. Let's look at the sales view. We can see the results of our calculations of quantity times price, and everything seems to be rolling up properly to all products. Let's look at the rule file. Right now, skip check is turned off, and our feeder is turned off. Only the sales calculation exists. The pound sign comments out the skip check and the feeder, so they're not activated at this point. So if we look back at our sales view, everything looks okay at this point. Now, if we turn skip check on, we're turning on the consolidation algorithm, fast consolidation algorithm, and we recalculate. Now we've lost our totals. Nothing's rolling up to camping equipment because those are all rule-driven sales. And skip check is skipping those because he thinks they're zeros. When we look and do check feeders, we can see that those cells are not fed. Let's close that. Let's go back to our rule file and let's add our feeder. Get rid of the pound sign to activate it. Click save. And let's go in the cube and recalculate. And now our totals are back. And now our cube is operating at peak efficiency, getting the totals from each one of those calculated values. Let's close this. Don't need to save it. Exit here. So one thing we didn't talk about were views within our cube. And views are simply specialized arrangements of a cube. So we have one that's revenue by product that we can browse. And with a view, you can rearrange the dimensions any way you see fit. Just moved accounts to the rows and put products back up into the context. Right now, products, years, and regions are in the context, and accounts and months are your rows and columns. You can expand and contract within a view. You can also select another year. So now we're looking at 2017 for Europe. So the entire cube right now represents data from Europe in the year 2017. Now we can look at data from Latin America for 2017. You can also put the years into the columns. Select total year from our months dimension, so we see the totals. Then we can put zero suppress on columns to get rid of all the zeros and see only years with data. So that's how a view works. Practice is to write your rules. and then write your feeders. For complicated rules, especially rules pulling data from another cube, it's best to leave skip check turned off to ensure that your rule is accurate. If it is, then you can add skip check and add your feeders. With the feeders added, check your consolidations to ensure they are correct. Test your data by using zero suppress. Rule-driven cells that are not fed will disappear with zero suppress turned on, as we saw in our example a minute ago. Well, that's our presentation on feeders. Thanks for watching.